Just focus your mind on the Mediterranean as it exists today. I mean, that shimmering blue expanse that cradles about 3.7 million cubic kilometers of water. It's a world-renowned destination for trade and travel, but get this, there's a startling paradox hiding right beneath those waves. See, several million years ago, this entire basin wasn't a sea at all. It was a blindingly white, scorched salt desert. The water just vanished, leaving behind a hypersaline abyss that stretched miles below the global sea level. Today, I'm going to walk you through how a thriving modern sea became a salt-crusted, hellish void, and how it was resurrected in a geological blink of an eye during the most violent flood in Earth's history. To really get how a sea simply vanishes, you have to look at the Mediterranean's anatomy. It basically functions as a massive, enclosed bowl with a single, precarious leak, the Strait of Gibraltar. Because it's so isolated, the basin actually holds a higher salt concentration than the North Atlantic. It's this fragile equilibrium, really, where the rate of water flowing in barely counters the rate of evaporation. Sunlight beats down, water turns to vapor, and the only replenishment comes through that narrow gap. Now, if that connection were severed, just imagine the math of the Mediterranean becoming terrifying. Blocking the Atlantic inflow would trigger a drop in sea level of about 1.65 meters every single year. It would be a slow, persistent drain, a ticking clock that would eventually strip the basin bare, exposing the deep seafloor where the Nile River once carved its path. Around 6.5 to 6 million years ago, that clock started to accelerate. The Mediterranean was physically severed from the Atlantic Ocean as the Guadalhorce and Riffian corridors closed. It was effectively sealed. This wasn't some minor leak. It was a total shutdown. With the Atlantic inflow cut off, the sea began losing a staggering 3,300 cubic kilometers of water every year to evaporation. This geological seal ignited what we call the Messinian salinity crisis. It was a slow-motion collapse that transformed a thriving sea into concentrated brine, then into thick salt deposits on the former seafloor, and it caused some truly violent erosion of the continental slopes. The speed of this disappearance is honestly hard to fathom. The Mediterranean Sea evaporated nearly completely within 1,000 years of the final closure of the strait. What remained was a desert basin of haunting proportions. The water levels didn't just dip, they plummeted. The basin dropped 3 to 5 kilometers below global sea level, an abyss 2 miles deep, leaving behind a blinding, salt-crusted void where an ocean once thrived. What was left behind was an uninhabitable wasteland. The exposed land transformed into vast salt flats, completely hostile to life because of the intense salinity. But the true horror really lay in the depth. As the water retreated, the Nile and Rhone rivers didn't just end at a coastline. They carved deep canyons into the earth, slicing valleys and gorges into the crust as they raced toward a basin that was now kilometers below the surface. If you were to descend into these deepest canyons, reaching 5,000 meters below sea level, the heat would be suffocating. Because of the extreme depth and atmospheric pressure, temperatures approached 80 degrees Celsius. For context, the highest temperature ever recorded on Earth is 54 degrees. This wasn't just a desert, it was a pressurized, salt-crusted oven, nearly 30 degrees hotter than the most extreme heat measured in human history. So, how do we actually verify this? The answer is buried beneath the waves. During the 1970s, researchers drilling into the deep seafloor pulled up sediment samples that revealed a startling discovery: evaporite minerals, soils, and fossil plants trapped in the rock. The scale of the salt was breathtaking. Instead of a thin crust, they uncovered a kilometers-thick evaporite sequence. In certain locations, this salt layer reached a thickness of over 3 kilometers, literally a mile of pure salt and gypsum. It's jarring to realize the entire floor of the Mediterranean was once a giant, white, crystallized crust. Beneath the Pliocene sediment, ancient erosion features remain preserved, allowing researchers to calculate the violence of the refilling event. Based on these features, geologists estimate that when the water finally returned, it plummeted down a drop of more than 1,000 meters. This shift was a biological catastrophe. As the water vanished, animals living near the Mediterranean faced a brutal choice: migrate or perish. The remaining water became so shallow and saline that it could no longer support complex life. For the majority of species that called this basin home, the abyss became a trap. The entire ecosystem collapsed under the weight of the accumulating salt, wiping out nearly everything that could not adapt to the extreme brine-filled environment. For 50 years, the dominant scientific model was the nearly desiccated basin hypothesis. This suggested that at the peak of the Messinian salinity crisis, the floor was almost entirely dry, broken only by a few hypersaline pockets, kind of like the Dead Sea. However, the narrative shifted around 5.5 million years ago. Wetter climatic conditions increased the volume of fresh water from rivers, which diluted those salt lakes into larger pockets of brackish water, comparable to the Caspian Sea today. This transition, often termed the Lago Mare event, represents the final stage of the Messinian crisis. Some researchers argue this resulted from the overspilling of the Paratethys waters into the Mediterranean, introducing brackish water fauna like ostracods and mollusks. Yet, a mystery persists. Messinian deposits contain Atlantic fish, and the sheer volume of salt suggests some remnant flow from the Atlantic existed even before the Zanclean Flood. It's possible that interconnected seas remained hidden on the floor of the Mediterranean, keeping the abyss alive in secret. Then, the dam broke. Approximately 5.33 million years ago, the Atlantic Ocean breached the Strait of Gibraltar, triggering the Zanclean Flood. This wasn't a gradual rise in water. It was a megaflood that violently reconnected the Mediterranean to the Atlantic. The pressure was staggering. Water rushed down a drop of more than 1,000 meters, plummeting into the Ionian Basin. The maximum discharge was about 100 million cubic meters per second, a flow 3 orders of magnitude larger than the modern-day Amazon River. The Mediterranean basin was inundated. Sea level rise within the basin may have reached rates exceeding 10 meters per day. The ocean reclaimed the basin in a geological blink of an eye, ending the Messinian salinity crisis and ushering in the Zanclean Age, the earliest epoch of the Pliocene. Now, in the 1920s, a German architect named Hermann Sorgel proposed a plan that sounded like science fiction: drain the Mediterranean. He envisioned a massive hydroelectric dam at the Strait of Gibraltar to generate renewable energy for Europe and Africa. The project collapsed because there was simply insufficient concrete in the world to build such a structure, not to mention the geopolitical reality of the time. But had Sorgel succeeded, the consequences would have been global. Draining the sea would have caused a 10-meter rise in global sea levels, submerging cities like New Orleans, Sacramento, Amsterdam, Copenhagen, and Shanghai. Rainfall would have declined across southern Europe and Turkey, leaving the land irreversibly parched. Is this cycle of salt and water truly finished? Well, the Earth's crust is not static. Due to the continued northward movement of the African tectonic plate, the Mediterranean basin is being compressed. This slow, relentless pressure is not just altering the coastline, it may eventually obliterate the Mediterranean altogether. The sea we see today is merely a temporary bridge between two continents. We are effectively watching a future mountain range in the making, not a permanent ocean. We've traversed the history of a basin that transitioned from a shimmering blue sea to a blinding white salt desert, and then endured the most violent flood in our planet's recorded history. The scale of this transformation is just immense. A basin that plummeted 5,000 meters deep, a void reclaimed by the Atlantic with a discharge of 100 million cubic meters per second. This serves as a reminder that the ocean is not a permanent fixture, but a volatile, fluid reality. The Mediterranean is a scar of a prehistoric catastrophe, a body of water currently caught between tectonic plates that are slowly squeezing it out of existence. As Africa continues its northward drift, the geography of the planet will shift once more. When will the next great change occur? And what will the final days of this sea look like?